Hi, welcome to the channel. I'm Lauro Miller and I make videos about programming. Today we covered destructuring, and actually we talked quite a bit about it when we covered objects, arrays and other topics in the past, but I just wanted to make a big summary and perhaps cover one or two little topics that I missed. So the goal for today is to go through destructuring in details, talk about how it works with objects, with arrays and other specific topics that we need to keep in mind. So let's switch Notion, let's check the agenda and let's get started. Here's what we're going to talk about today. We'll start with discussing the main use cases for destructuring. We then move on to talk about object destructuring, array destructuring, how we can destructure return values from functions. We'll talk about setting default values for destructuring and how nested destructuring works. New file here, and the first one is going to be usecases.js. There are three main scenarios or three main cases where destruction can be really helpful. The first one is when we are declaring variables. The second one is when we are handling function parameters. And the third one is when we are performing assignments, so variable assignments. Now let's go through one by one. Let's go through each of them in details. The first one, when we are declaring variables, is basically, well, let's say here I want to declare a variable, so maybe I can have another object, so const person, and this is going to be equal to some object. It's going to have a first name of John and an age of 30, let's say, age of 30. And then if I want to declare a new variable with the first name from this person object, I can use destructuring by simply using the syntax const first name is equal to person. What this does, as you probably already know from previous discussions, is it creates a variable called first name, uses the const keyword, which means this first name here cannot be reassigned in the future. And because we are using destructuring here, so we are saying const first name equals person, this is going to have the value of the first name property from this person. If the person has no first name property, this is going to be undefined. For arrays, this is pretty much the same. So if I were to say const numbers is equal to 10, 20, and 30, then here I can say const 10 is equal to numbers, and this is going to destructure the first element from the numbers array into a new variable called 10. If I were to, at the bottom of everything, console.log first name and console.log 10, then I should get the exact results that we expect. Let's switch here to the terminal and let's run node use cases. And exactly we get John and 10 printed on the screen. The second use case is when we are handling function parameters. So let's say that we have a function, and this function is going to be, let's create an arrow function, print object. And this is going to receive some object and we want to destructure some of its elements. So let's say we want to destructure first name and last name. And then here we'll simply console.log the first name and console.log the last name like so. So now as you can see, when we use destructuring from within the function parameters, this is already automatically creating a new variable called first name and another new variable called last name. And if the object that we pass as an argument contains any of these keys, it's going to populate this variable accordingly. If the object has no key called first name or last name, then these variables are going to be undefined. Let's maybe here try to have a new object, so const person, and we will have just first name. I'm going to say first name is Jane, and then age is going to be again 30. And if we were to print object with person, then you will see that this is going to print here for the first name is going to print Jane, but for the last name is going to print undefined. Let's run this, and as you can see, that's exactly what we get. So there is no error thrown by JavaScript, we simply get undefined as the last name. Now, of course, be careful when working with undefined. If you try to, for example, last name.length, then this is going to throw you an error, because since last name is undefined and undefined values have no properties, then the length is going to actually throw you an error. Let's give it a try, and here is the error. So we need to be careful, at least if you're using vanilla JavaScript, you need to be more careful. If you use TypeScript, which we will use in future series, then all these checks are going to be performed by the TypeScript compiler, and it will go a very long way in ensuring that we don't do this kind of mistake. We can also use, of course, array destructuring here. So we could say print first two elements, and then we can use the array notation here. So that would be the first and the second. And we could even pass additional elements here, but only the first and the second are going to be printed on the screen. So I'm just gonna clear up the whole thing. Of course, if I am not careful and I pass the object to the function, then I'm gonna have an error. Let's save this and let's try to run. And of course, you will get an error here because we are not able to destructure this whole thing. Now, if the person were, let's say, or instead, let's use again our numbers here, numbers, and this is an array of 10, 20, and 30, then this is going to be fine, right? So if I save this and then I run the whole thing, I get 10 and 20. One small comment I want to make here is that if we use destructuring like this directly in the function parameters, we can actually change the value of these variables within the function, right? So we kind of lose the power that we have when using const, when ensuring that the variable cannot be reassigned. If we use destructuring directly here, then we will have this freedom. It's kind of using let and then being able to reassign the variable afterwards. Let's save this. Here I'm gonna clear the whole thing and then run. You will see that we have reassigned the first variable. Now there is, of course, a way around this, and it is to not do the destructuring directly in the parameters of the function, but to say, for example, params, something like this, and then you can use const, and here you would have the destructuring. Right, so if you use const from within the function and then you do the destructuring of the parameters, then you cannot reassign it. So this is a safer way. And to be honest, I actually like this approach more than the previous one because it makes the code a little bit cleaner. Also, when we start working with TypeScript, where we will type the parameters, then it's going to be quite clear how we are defining the shape of the function, and then we are doing the destructuring from within it. So I like this syntax. I think it's cleaner, but again, it's a personal preference, and if you want to do it differently, that's also fine. It's just be consistent in your code. The third main use case for destructuring is when we are performing variable assignment. So let's say that we have here, let me erase this. Let's say we declare two variables x and y, and then we have some array of numbers of 10, 20, and 30. And then we want to assign the first element of this array to x and the second element to y. Then we can simply do something like this, x and y is equal to numbers, right? So this is going to assign the first and the second element of numbers to x and y. If I want to assign the first and the third elements, then I can just add a comma in between here. The second element is not going to be assigned anywhere, and then we have the first element in x and the third element in y. Let me save this and let's run the code in the console. And of course, I forgot, I need to print, right? So console.log x and console.log y. Let's see the result that we get in the console. Exactly, 10 and 30 as expected. That's it for the main use cases. Let's now briefly talk about object destructuring. To be honest, I don't think that there is anything new. So objects.js, I will just review some of the main topics. So let's start with a simple object, const address, like so, or address, and we'll say street. That's going to be some street. We will have a number, and that's going to be 10. We have a zip code, and that's going to be 100, and we will have a country, which is going to be, let's say, Germany. Now, as you already know, we can access or we can destructure specific properties of this address object and also the methods, but let's stick to the properties here. And we will say, let's say we want to destructure the street. Now, this is what is called a property shorthand. We are doing the destructuring and the assignment to a new variable all together. And that's because the street, the name of this variable matches the name of the property in the object. If I want to rename this, I can add a colon here, and then let's call this, for example, str. Now the name of the variable is str, and it's going to contain the value of the street property of my address object. If I were to come here and console.log str, then I'm gonna get the expected result. Let's clear the whole thing, node objects.js, and then I get the result here. Now, one thing that I already mentioned quite a few times, but in case you forgot, you can also use the REST operator. If you were to add the 3 dots here at the end after destructuring all the properties that you want to destructure explicitly, then you can add the 3 dots and say remaining props and methods. And if you were to console.log this, then this is going to print the number, the zip code, and the country. Right, so here, of course, it's not printing all the methods that are that are available in an object because of that whole discussion about being enumerable or not. But for our cases here, it's just enough to understand that whatever properties and methods we don't explicitly destructure, they can be grouped together in a new object by using the REST operator. And just keep in mind that the REST operator has to come last. So if we were to actually try to access something after, so let's say the number here, and we try to put this here, then this is not going to work. If I update the code here and then I come to the console and I run this, I will get this result which says that the REST element must be the last element. So REST element always needs to come last, and that's also valid for arrays. Quite a quick discussion about object destructuring. Let's just, again, a similar discussion about arrays is going to be quick as well. We're going to call this arrays.js, and let's see how we can use destructuring with arrays. So here's pretty much the same thing. Let's call this letters, for example, and this is going to be, I don't know, A, B, and C. And if I want to access the first element here, I can simply say first letter is going to be equal to letters, and this is going to destructure the first element of the array into the variable called first letter, and I can use the REST operator to group together all the remaining letters into one new array. Now if I were to console.log remaining letters and save this, let's come back here to the console and clear everything, and then we run node arrays.js, then we have the remaining letters. Similarly to objects, I cannot use the remaining letters in between, right? So we cannot use the REST operator to kind of access the first letter, then group all of the letters in the middle into one new array, and then access the last letter. If I were to try to do something like this, then I'm going to get the exact same error that I got with objects, meaning that the REST element must be the last element. So let's save here, let's mark this as completed, and let's talk about destructuring return values. And this is more of a pattern rather than something new, because basically we can return from a function, we can return a primitive value, we can return an object, we can return an array. Of course, we can return other types of values or of constructors or elements in JavaScript, like maps or sets or weak maps or weak sets. But here, for our purposes, just think that a function is going to be pretty much, it's going to output either a primitive value, an object, or an array. And once we have this result, then we may actually want to execute, to do a bit of destructuring on the return value of the function. So let's call this return values.js, and let's see how we can use destructuring here. So for the sake of an example, let's say we have a function which extracts the first and last words, and it receives a string. We will assume that this is already a string. We're not going to add any checks here, but we could actually see if type of str is different than string, then we can simply throw new error, just like this. I mean, when you have only one statement in the if block, then you can omit the curly brackets. I prefer to always use them. It makes readability, or it improves readability. So my suggestion is to always use them, even if you have just one line. Now, if it's not a string, it's going to throw a new error. Then let's say here, please provide a valid string. And then we can split the string into words. So str.split with an empty space. Oops. with an empty space, and then we can return the first, which is going to be words at index 0, and the last, which is going to be words at the index words.length -1. So if you try to use a negative index here, that's not going to work as expected. So the cleanest way is to simply use words.length -1. Of course, here I'm assuming that the words are going to be separated with a single white space. It could be the case that there are more white spaces and we need to remove the empty elements from this words array, but for demonstration purposes here, that's enough. So we can access directly the result. So let's say we want to access the first key of the object by destructuring the return value of the function. So if I now call the function with, let's say, John Smith, for example, and then I console.log first variable, this is going to work as expected. So node return values is going to print John on the screen. And if I were to access the last, this is also going to work just fine. Even if I have something else here in the middle, then this is going to print Smith on the screen. Of course, this also works with arrays. So if I were to return directly the str.split here, then I can access the first element by destructuring it from the array. First, like so. So saving this and running this gives us the same result. Okay, let's mark destructuring returned values as completed. Let's move on to talking about default values. And default values are actually very important because they allow you to, so let's call this defaults.js. And they are very important because they allow you to define a certain predictable value in case a certain key or a certain property of an object or of an array is not available during destructuring. So if I were to have an array here, let's say of letters with two elements, A and B, and we wanted to access the third element of this array, then of course it's going to be undefined. So let's skip the first two and destructure the third element. We're going to say this like so. So remember, when we have empty spaces here in the array, we are simply skipping the objects and we're trying to access directly the third element. Now, if we were to console.log the third element, then this is going to print undefined on the screen. Let's clear this and run node defaults.js, and it prints undefined. If you want to prevent third from being undefined, you can actually assign it a value like so. So by providing the equal sign and then the default value, and once we print this on the screen, if the result of the destructuring is undefined, it's going to actually assign the default value to that variable. Now, if this is anything else other than undefined, even null, the default value is not going to be assigned to the variable. It's going to have null. So third is going to be null here. If I save this and execute, third is going to be null. If this is undefined and then I save this, then the default value is going to kick in. So also be careful when you are actually, if you want a value to be undefined, then do not assign a default value, because if destructuring encounters a default value and it has, or if structuring encounters an undefined and it has a default value, then it's going to prefer the default value. The same thing is valid, of course, for objects, as you already know. So just a simple person here, name is going to be Max, and then we will try to destructuring a non-existing property from person. This is going to be undefined, and if we want to prevent it from being undefined, then we can assign a value, let's say John, or maybe here it could be the last name. We could actually be a little bit more precise. Last name is going to be Smith if the person has no last name, or even it could be an empty string, for example, so that you can do some operations with it. So if I were to console.log last name, in this case, it's going to console nothing. It's going to output nothing because it's an empty string. Let's just give it a try. And as you can see here, there is one white line or one blank line, but there is nothing printed because this is just an empty string. Of course, if I were to pass a value here, then it would print it on the screen. And this is one way that we can ensure that our properties are going to have at least some default base value that we can work with. Great. Now, last but not least, let's talk about nested destructuring. And nested destructuring is basically, well, we if we destructure a certain property of an object or a certain element of an array, and that property or that element of the array, they are an object or array themselves, then we can chain a couple of destructurings so that they are at least a little bit more, or they are condensed, the code is a little bit more condensed. But I mean, you need to judge by yourself if you want to do this. If there are too many destructurings or too many nested destructurings, I think this hurts a little bit the readability, but again, it's your choice. So let's say we have a person here, and this person has a first name. The first name is going to be John. It has maybe some middle names, and this is going to be an array of strings, and that could be W, and that could also be, I don't know, S, and that could be also be J, for example, like so. And then it has a last name, that's going to be Smith. Then it has an address, and the address is going to be an object. It's going to have a street, and I'm just going to put a street and number here, so some street, and number is going to be 10, like so. So now if I were to destructure the address of this person, so the address of this person, that's going to be like so. And this address here is going to be an object itself, which means I can chain a destructuring operation here by adding a colon and then opening a new object. Now here I can access, for example, the street property from this address object. If I were to console.log, oops, street, this is going to correctly output some street. Let's clear this and run node nested.js that outputs some street. The same for arrays. So if I have here, we are destructuring the street property from the address object or from the address property from the person. If I were to say middle names and then open an array here and say first middle name, this is also going to be valid. If I were to console.log first middle name here, then it's going to print W on the screen. So it's possible to chain and have a little bit of a more concise syntax here, instead of just doing const address or address and then middle names, and then at the bottom here we would say const first middle name is equal to middle names, and that is perhaps a little bit more concise if you just cut this and do it directly here in this object. Now, once again, if we start doing too many destructurings, let's say that middle names is actually an array of objects, and then we start trying to destructure some of the properties from the object, then things can start getting quite confusing quite quickly. So just be careful and don't overuse it, because it can make the code quite confusing. Of course, if we try to change some nested destructuring to an undefined property, this is going to fail, right? So if I were to say here, or even not even to an undefined property, but to any property that does not match the expected shape. So if I were to, let's say, try to destructure the first last name here, first last name, then of course this is not going to work, because last name is a string. Actually, sorry, this is going to work because a string is behind the scenes an array, so, or an array of characters. If I execute this, it's just going to extract the first letter, but let's maybe try to do this with the address. Sorry for the bad example, but here, if I were to try to extract the first element of the address, then yes, I'm gonna get an error because it's not possible to do that, right? So just be careful with the shape of the elements, with the shape of the properties and the shape of the objects you are working with, because, well, it can get quite confusing, as I already said, and you can spend a lot of time trying to find where exactly the error is. My advice is this nested destructuring, it can be useful to improve readability as long as the shape of the object is not too complex. If it becomes too complex, then maybe a few additional lines are going to help, rather than, well, yeah, I think that then a few additional lines are going to improve the readability of the code. That's it for today, a pretty light video after a heavy one about arrays, and in the next video we start talking about asynchronous programming in JavaScript. Asynchronous programming is the last big topic we'll cover in this series, and it is perhaps the most important, also because it's the most advanced and the hardest to grasp. So you definitely don't want to miss that, and you know what you have to do, you have to subscribe to the channel to get a notification when the next video is out. Thanks for your time and I'll see you in the next video, bye bye!